Welcome, welcome, welcome. And wow, episode 18. Interesting. Well, where are we up to, Model 3D? We've actually got quite a bit done over the last couple of episodes, that is correct. So I'm a lot happier. We're on the correct trail now, so let's open up our files and see what we need to do here. We have headers, we have source, and I'm just trying to think, is Model Warehouse worth opening? Yeah, well, so we were still doing the object loader, weren't we? But we had got a lot further with it. Oh God, I do need coffee. Coffee time. Already, yeah, come on, don't hit the microphone, good boy. So we've now got our face element, haven't we? And that was the biggie. So we need to send our data to the API. And the problem that we face at this point is a simple problem. Our data is in the wrong format. Our data is in the format of a .obj file. And it's not a problem, but we do need to convert it. So we'll convert it and send it. That seems fair enough. Let's get this obj loader open. So store obj, we're doing send data to API, the create model, which is in the API, obviously. Yes. Let's see, do I need anything else in there? No. We don't need that anymore. That was just me overthinking things. Which means we don't need that anymore. There's no need to initialize. We can get rid of that line altogether now. That's good. Two things gone, because we're actually passing create model in to the send data. There's no point in storing it. We don't need to store it. So that's the first changes. Store obj. Yeah, let's go. So that can stay. Initialize is empty anyway. We never did it. Good. Ding. There we go. And if we come down to store, send it to API. Yep, that's all we need. We can just start with a blank line now. Great stuff. That's a lot better. Oh gosh. I think I might be coming down with a cold. I hope not. Colds and me don't really work very well together. Now, I've just said all our data's in the wrong order. Well, yeah. So we're going to have to put it in the right order. Now, from experience with this already, we know what we need now, which is good. So let's tell ourselves what we need. We are going to need a standard... No, it's not... What are we in? We're in Qt, aren't we? Yeah. Oh, fantastic. So it's QVector. Magic. Yeah, I'm already starting to like this. We haven't even got anywhere. So QVector, and it's going to be an unsigned int. I think Qt has uint. Yes, it does. That's not. No, I'm going to keep it in full. Don't be lazy. I prefer that to uint anyway. And as you notice, there's no star. The reason for this is because I'll show you. This is going to be the index, and I'm calling it an array on purpose because that's really what I've just created. And what I've just created is an array. As in, that is the same really as saying index 225 or something, but without a number. So, yeah, it would be unsigned int. I'll just call it int for now, being lazy. It's the same as saying unsigned int, index, array, open brackets, don't know, close brackets, semicolon. That's what I've just typed. Now that is interesting, isn't it? There's also another interesting thing about it, is that it's scoped. It resides within this scope, the two brackets. So when we get to the end of this scope, it dies, it disappears, it gets erased automatically for us. Whereas all of these are still hanging around, if you remember. Oh dear. I'm going to be struggling all the way through this now, aren't I? I hope not. Yeah, so those are the two things to keep in mind as we go along. Firstly, we've just written an array in a different format. And secondly, it dies. It can only be used within this function, within this scope. So let's have a couple more of these Q vectors. Are quite nice. I like them. Don't tell anybody that I like them, but I do. So we're going to have a couple of floats as well. And what we'll have is our positions array. I'm wording these on purpose because these are matching our GLSL, our shaders. Because that's what we need to convert to. We need to convert now all our data so that we can put them onto the graphics card in a format that can be used for our graphics card programs, our shaders. So that's what we're actually doing. I'll have another float, please. If I was being pedantic, these should all now be GL unsigned int, GL float. But I'm not being pedantic, so I'm not doing it that way. This is going to be color array. And that's all we had. Those are the only things that we really used for the OpenGL. Do we have it on the GFX card? No, we have it here, don't we? Okay, I can show it from here, can't I? Create shader. No, that's no good. Create model. We haven't even put it in. Ah, here it is. It's all here. So what we need is our position buffer, our color buffer, and our index buffer, and that's all we've used, or all we're going to use, should I say. So we'll get rid of those. Thank you. So that's these three items. So we've actually made it easy on ourselves. That's it. And now all we need to do is go through all of the data that we've read in and put out there in the programming, in the machine's memory somewhere, floating out there in what they call the heap. I should really go through that. I think I'll do that in the next series, stack and heap. I think that's where we'll start, because it's getting too hard to explain some of this stuff. So I'll go with an unsigned int, because I've already used one. Int. We'll have a count. We'll just count through our face elements. Yeah. So our face elements start at 0. Because remember, our face elements have all the indexes to everything else. And we're going to have to put everything using those face elements into the correct order. So we're going to have to start there, and that's in model. We're in model, aren't we? Yeah. And it's just going to be m_face I'm trying to get this right. Face element, and it's dot size. Yeah, that's right. Excellent. And we just go increasing by count. Is this going to work like that? Well, yeah, but we have missed something. Because we need to know how many vertices there are. And we're just going to put that as an unsigned int again, because obviously it is. Vertices per face, and that equals 3, because we're doing triangles. We are not doing quads. I'm putting this in. I'm sorry about the coughing. I'm putting this in because I know that at a later stage that I do want to include quads, because I might not just rely on GLDraw element as a renderer. Where this example is designed for that specific kind of eventuality that we're going to use. My microphone's still in the wrong position. Oh god. There we go. That's better. Yeah, that's better. Sorry, I wasn't getting the full dynamics there. Right, so we're going to go through each face element, and we are going to take a look at each vertex. So, keep it as an unsigned int, I prefer them. And we're just going to call this, I'm going to call it iVertex, because we're going to use this as an index of the vertices. So that equals 0. And iVertex has to remain less than the vertices per face, in this case 3. That's why I wanted that variable, because it might be 4 if we're doing quads at some stage, and I just need to make this as flexible as possible. I think that's a better way of putting it. You can just put 3 in there if you want. You could just put, for int I equals 0, I less than 3, I plus plus. That's valid. I'm just being a bit more generic, maybe. I don't know. Flexible? Don't know. Pedantic? Probably. Okay. Now, we've got that. We've got to work through each of our index array, position array, and color array. And my throat's starting to get better. Excellent. Keep the coffee rolling whilst my throat decides it wants to play. So let's deal with them one at a time. Index array. And all we're going to do is push back a number for the index. And the first time we come in here, the index is going to be 0. How do we get that? Well, it's the count. And it's multiplied by the vertices per face, which is 3. So the third time it comes, so that is always going to be 3. In this case, it could be 4 if we're doing, so we've got that variation. And we have to plus the I vertex on, for which part, or which number, for which index we're actually looking at in that area. So the first part gives us how many times we are going through the outside loop, in other words, which face, and the inside part, the I vertex, equals the part of that face, i.e. the first parts of the numbers. There's 3 parts to it. It's down below, isn't it? You see, there's 1, 2, 3 parts of it. So that inner loop is going through 1, 2, and 3. But as we know, we have to come down 1 because of indexing and the way that the computer stores it versus the way that the .obj stored it. So it starts at 0, our interface. Get back to where I was. Thank you. So yeah, that's how it's working. This inner part has to go through all the 3 of them. And that's that. That's our index. Our position array. How are we going to do this? I don't know. But hey ho, we'll make it up as we go along. How about that? That's the Blades way. Push back. What are we actually going to push back? We need to push back the vertex. The actual vertex from the face. Now, did I actually do this or not? Index array pushback, yeah. It's quad, yeah. Position array pushback, the vertex data. I'm thinking that it's that one there. It's not -1 because we should have put the -1 here. Good, we did. So it is that without the -1. I'll take that. Where's the bracket? Copy. I'm going to take that because that's what my thoughts have been so far. This is not C++, this is Qt. So M vertex, it's face elements. Element. Index is the inside loop, isn't it? No, it's not. Index is the outside loop. Okay, let's see if I can get this right. Okay, let's go through this step by step. Right, so we've got the M vertex data, which we have stored in vertex data here. We then open a square bracket because we want to find the number of the vertex data we want, and that, of course, that index to the actual vertex data is stored in our face element, and our face element is correct. It's going to be count. Yeah, it is. That is the outside one. So that's our face element because that's where we're looking through them. So this is face element count that we're looking at, and that will give us this last bit, which is all wrong here. Let's see what it gives us. So if I put a dot there, it gives us the vertex index, and we need to know which vertex index we're looking at, which is now going to be I vertex. I vertex, is this looking better? Yeah. I vertex, that's correct. We can close that now. And which one are we closing? Yeah, it's going to be, we need a number. So it's just I vertex, isn't it? I vertex is the number. Tell me that's an int. You going to give me any help here, computer? Okay, so face element m vertex index I vertex carries an integer. So once we know what that is, we know what the data is. So we can close the bracket. And then we need to close. Oh, this is awkward. I've got brackets here that I don't know what to do with. So that is face to there. That's the M vertex data, yeah, got it. Close that. That's correct now. And we want X, please. Yeah, we want the first number. Perfect. That is perfect. So we need to push back the first float, or the X value. Does that work? It does, but it should give us an error. Well, give us that. Warning, implicit conversion changes signedness, unsigned int to int, which is perfectly right. And it's on what we've got inside of here. It's this vertex data here. It's there. Face. Yeah, it's the face element count. Yeah, as you can see, it's underlined it for us. So that is an unsigned to int. We want to cast that to an unsigned int. Or do we? Otherwise, we'll have one here. Hold on a minute. It's complaining about count, so let's just get rid of that and see what else it complains about. Yeah, you're watching. There we go. Perfect. Now that's what I would have thought is better. Why hasn't it complained about that one? This one I expected. That one I didn't, sorry. I'm going to do a static cast on this one. To unsigned int. And we're just going to put brackets around this whole lot here. There, please. Now you're doing an implicit from int to unsigned int. Okay. Get rid of the extra bracket, please. Gone. It is quiet once more. It was just that count then. Why isn't it calling me out on the I vertex? Interesting. I would have thought it would. Let's see if it does. No, it doesn't call me out on the I vertex. How interesting. Right, well, this is going to be obvious, but we're just going to copy this line. Copy. And we need to do it 4 times. And at the end of each one, we just need to do X, Y, Z, and we did W as well, so we'll do W as well. There you go. And does that make sense now? That we are taking the first index, and we are taking the X, Y, Z and W numbers and pushing them back into our positions array. So that is going to work through all of the elements, each face element, and take out one at a time from each of these vertex indexes here that we push back, the X, Y and Z. Then it'll go on to the next one, do the X, Y and Z, then it'll go on to the next one, do the X, Y and Z. We now have to do this for colours. I think that's right. I should really be checking this, shouldn't I? I think that's right. I'm going to trust myself. Colours. Whoops. Colour array. Dot. Push back. Open. Well, it's not M vertex data anymore, is it? It's going to be M. Which one is it going to be? Come on, can you guess? It's going to be diffuse colour. That's right. The colour that we got from the MTL file we need. Don't know how we did it. KD. There we go. Diffuse colour. Push back. And we pushed back a float, float, float. So it's only 3 floats we've got for that. We don't have the alpha. So we're going to have to find the alpha from somewhere, aren't we? Because we want it. Let's be honest. Diffuse colour, and it's going to be which one do we need? Again, it's coming from the current colour that we stored in the face. So the face stored the current colour. So it's diffuse colour, and it's going to be M underscore face element. And that's going to be count, isn't it? Please tell me it's going to be count. Yeah. And that's working within my brain. And which one do we want? We want the current colour. Yes, we do. So dot should have current colour in these. There it is. Current colour. And that will be straight. That gives us a value. Current colour dot. There's no dot. It just gives us a current colour. So that's that. We've now got an integer, haven't we, computer? Oh, you're not going to tell us again. I've also got double brackets here for no reason whatsoever. Thank you. So I'm taking the diffuse colour, blah blah blah, current colour. So that will tell me which colour we are in. 1, 2, 3 or 4, sorry, in this case 0, 1 or 2, and then we need which value? Red. Thank you. Done it. Done it. Gotcha. That's the value I want. I want the red. And that means we have to do this 3 times. But blades we want 4. That's right, we do. So I want a red, green, and blue. There we go. We don't have the alpha. Or do we? I think we do. So let's see if we can find it. Colour array. Dot. Push back. We want the alpha. Underscore. Back, yeah. Open brackets. And it will be... Oh my god. Which one will it be? It will still be part of the current colour. Will that work? So it's M. It's not diffuse colour now. It's transparency, isn't it? That's what we called it. And that will be for M underscore face element. And that's the count. Yeah. So far I'm with it, I'm with it, I'm with it. Yeah, I'm with it. We'll still need which colour we are looking at. M underscore current colour. That one. Then we close the brackets. And then if we put a dot, it gives it us the value we want. M transparency. Fantastic. So these are the values that we are reading in. Oops. We're reading in the X, Y, Z, W of each colour, and then the RGB alpha of the colours. Wow, that's worked. I'm shocked. I'm shocked that it's worked so nicely. And then all we need to do is send that off to create model. And create model has to accept this data. So we are sending this data to load into the graphics card. So it's load to GFX card. What we're going to create model to do this? Anything? Have we programmed anything? Nope. So let's program something. We're going to need just that data, aren't we, really? And it's going to come in as arrays or pointers. So here we can make some pointers. We can have an unsigned int star index. Oh, I'm liking this. Index data, semicolon. We can make a float star position data. You seeing where this is going now? Float star color data. Now we need to receive it in. And it's going to be a void. It doesn't send us anything that we know of. Oh, you know I've done, don't you? You know what I've done already. I haven't put my M's on for member variables. We now know how important that is. As we can see the difference between scoped or local variables and member variables. Member variables we have to delete ourselves. Okay, sorry, I've just added a line without realising. What we're going to call it? Data. Let's call it load GFX card. And then what we would take in is unsigned int star index data. Remember, this create model is created for us by the model warehouse, or will be when we get around to programming the model warehouse properly. And this create model, the address for where this create model is stored, is going to be given to our obj loader store obj, and it's going to send it through to the correct create model, and that means we can then take information out of create model from within the model warehouse, which is going to be the data that we need, and that is going to be, what is it called? What we called it? The obj data structure, the OpenGL data structure. So we'll be able to take that data straight out of here. Wow, this is going to be good. This is H, isn't it? Sorry, I'm talking and I'm not typing, and I'm thinking, and I shouldn't be. Duh. Star position data. I'm not sure if we need these as member variables, you see. I don't think we actually do, but I'm just putting them up there for now, in case we do need them. But I don't think we do. We can just use them and send them off and then let them delete themselves, to be honest. Float color data. Depends how we use it in here. Sure. Oh. Guess who pressed his caps lock by accident? There we go. Put a semicolon there. Have we got... Hold on a minute, this doesn't look right. 1 second, I am checking something. Namespace model, I thought so. Namespace model, create model, yeah, that's okay. What we got in our create model here? Namespace model, blah, 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 blah. Let's put our thing there. Okay, I'm happier now. So now I can refactor that. For now, I'm just going to put m underscore. This may be taken out. Index data equals index data. This may be just useless, like I did with that other one at the very start. I just took it out altogether because it wasn't really needed. What we now position. Let's do it in the same order, and that equals position. M underscore color equals color. There we go. Fantastic. That's that done. So we can now send it all over, and it'll be received by a load GFX card. Excellent. So that's saved. That's done. That's saved. That's done. Store obj.h. Yeah, we'll keep that open for a minute. So our last line here, literally our last line here, will be, we've already got create model at the top. So create model, load GFX card, and all we have to do is type in the address. So it's going to be address of index array, comma, address of position array, comma, address of color array. Done. That's it. At this point, everything in here is destroyed. We haven't done a cleanup. So at this point, we should also be thinking about doing our cleanup of all our member variables, because we've now got a lot of data floating around in, on the heap, the main memory of the computer, that isn't needed anymore. What's wrong with it? Cannot initialize a parameter of unsigned int star with an R value of Q vector star. Okay. Put 0 on the end. Thank you. It needs the address of the first item. That's what it's saying, I think. Yeah, that's correct. Yeah, it wants the address of the first item in the array. That's the basis of it. Do we need the size of? We may do, because we're passing that over. I don't know if it's going to be able to get us the size or not. We are going to find out, possibly the hard way, and have to come back and alter it and get the size of everything. That'll be fun. Yeah, that's it, done. Not bad, hey? I'm happy with that. Are you happy with that? So we've now got, oh no, we want to do our, we've got clean storage. I'm thinking of putting that as private, because what we should really do here is, before we send it, well, it doesn't really matter, before or after. It does matter, because that will then do a function, so we can do it here. Just clean storage, innit? Clean storage, please. And what we need to do is, for every single M value that we have created, we have to delete them. So that's why I left the header file open, isn't it? Yeah. So I'll take the lot, actually. I'll take everything. All of these. Okay. So we're going to need 1, 2, 3, 4, 5, 6, 7, 8 of these. Whoops. One, 2, 3, 4, 5, 6, 7, 8 of those. The first one is going to be material file name. That is correct, yeah. The next one can be vertex data, which is already correct. Copy. Do make this look easy, I know. Copy and paste for the win. You should not program like this, ever. I'm only doing it this way because my typing is awful. What did I just do there? That was clever. Copy. So this comes after vertex normals. Face elements. Bye-bye, face elements. You were nice to me. You made my life difficult. Not. I actually enjoyed doing that part, I must admit. And material. Copy. We have to delete everything. Yeah, it's a bit of a bind. Could it have been done a different way? Yeah, probably. Actually, yeah, definitely. Oh, who am I trying to kid? Is this the best way of doing it? Dunno. I know it's the most versatile way of doing it. Is that a way of putting it? Because now, when I come to do things, I can add to this list very easily. And just all we do is we can add things in here. We then add them to here. And if we need them to be sent over, we add them to here. So really, you've got 3 functions that are doing everything. You've got your store data, your send data, and you clean your data. And of course, this one cleans up its own stuff automatically there. So all of our data is now deleted, which is why I never ever put anything in the destructor. Current color is possibly the only thing we need to put in the destructor, or have we taken care of it somewhere else? Okay, let's just have a quick look at it. It's just an int. It'll die automatically when this dies. It's not a pointer. Wow, that's got to be the cleanest class I've done in a long time. It cleans itself as it uses itself up, which it really has to do, because if you think about it, you don't want to be just loading one model. You want to be able to load multiple models, and you don't want to run out of memory after about the 5th model, do you? Because you splattered memory to God knows where. Yeah, I've got a couple of helper functions in private for storing vertexes and faces. This can now go. All my notes were helpful. Thank you for that. Glad I did that. Otherwise, I would never have got through this episode. Here we go. I'm happy. Wow, that's the happiest I've been about something in a while. In fact, I'm very pleased with that. So, in the next episode, what are we going to be doing? It looks like we've finished our OBJ loader. Well, we've finished it as far as our test goes. We haven't finished it as far as the end product would go. But we've got enough now to do a test. Fantastic. End of episode. You lot just take care, and my God, I'm having fun, and I'm very happy, so go ahead, treat yourselves, have fun.